Chatbots answer questions. Cowork does the work. It runs your files, tasks,
Claude
and apps.
Cowork is your AI coworker, a secure desktop agent that runs on your machine, works across Windows and terminals, and is available free through DDS Vibe Academy. In this session, we'll see how it operates on real files and applications to automate everyday knowledge work. Cowork goes beyond a simple chatbot. Instead of only replying in text, it can read, edit, and create files inside approved folders, execute workflows end-to-end, and interact with your tools. Think of it as a junior operations analyst embedded directly in your desktop environment. Claude Cowork reaches general availability on April 9th, 2026. It ships as a native app for macOS and Windows, included in paid plans from $17 per month. GA also unlocks enterprise controls, governance, role-based access, and spend limits, plus open telemetry hooks for CM visibility. This execution surface matrix clarifies when to use each Claude interface. Chat is ideal for conversational drafting, Claude Code for CLI-driven software work, Cowork for non-coding multi-step tasks on files and connectors, and Dispatch for handing work off across devices while you're away. Cowork chooses tools using a priority ladder. It prefers structured connectors first, because APIs are fastest and most reliable. If those fail, it falls back to browser automation in Chrome. Only when necessary does it use direct desktop control, which is slower and treated as a last resort. Our first build is a morning brief. Every weekday at 7 a.m., Cowork pulls from Gmail, your calendar API, and a reports folder to assemble a one-page summary. The output is saved into a briefs directory, giving you a consistent, automated start to each workday. We start by defining the objective and inputs. The objective states the recurring task. Generate a one-page morning brief at 7 a.m. The inputs enumerate exactly what Cowork may use: your calendar, your email inbox, and the reports folder. Clear scoping is key to safe automation. Next, we specify constraints and steps. Constraints keep email access read-only and forbid sending messages, while flagging any side effects. The steps then walk through pulling today's events, summarizing priority mail, listing due items from reports, and saving the final brief to briefs. To deploy the scheduled task, we follow 4 stages. First, live test once to pre-approve tool grants. Second, schedule via cron for 0630 on weekdays. Third, explicitly approve the single write step. Finally, validate that the brief meets word count and formatting expectations. Build B tackles messy data. Cowork ingests a raw folder full of CSVs plus a columns txt schema, then outputs a single clean XLSX file into clean. This pattern turns ad hoc data dumps into a standardized spreadsheet, ready for analysis or reporting with minimal manual effort. For this data build, the objective is to combine every CSV in raw into one clean spreadsheet. Inputs are tightly scoped. The mixed CSV files in raw and the column mapping stored in raw columns text. Again, we teach Cowork exactly what it may touch and how the pieces relate. We then add constraints and validation. Cowork must keep a build manifest and never alter source files. Validation requires that row counts match the originals. Key columns are never empty, and the final spreadsheet is written only to the clean folder. This enforces data integrity. The build manifest pattern creates a visible record for multi-step jobs. Each agent, such as Claude Cowork or Claude Opus, is listed with its vendor, role, and output. This makes responsibilities auditable. You can trace which agent aggregated research and which generated code templates. Autonomy must be intentional. At the top of the ladder, autonomous tasks execute without asking, such as scripted blog publishing. Drafts-only tasks let the agent write while humans post, ideal for social content. Prohibited tasks, like financial actions, are blocked at the system level. Cowork uses a two-environment architecture. The native agent loop handles conversation, file I/O, web fetches, and local MCP servers. Riskier actions, generated code and shell commands, run inside an isolated VM across a permission boundary. Sandbox files remain separate from your real data. We enforce the rule of receipts. Every run must produce a receipt plus a validation step before work is marked complete. Logic gates, such as shell word count or schema checks, determine whether outputs move into the completed folder or are rejected for further review. Debugging mode 1 is overbroad scope. If the agent edits the wrong files, the diagnosis is usually vague instructions. The fix is to tighten the prompt boundaries, explicitly confirm allowed side effects, and, until behavior is stable, operate in a drafts-only configuration. Debugging mode 2 is blind trust. When you see silent drift or hallucinated data, it often means outputs were accepted without checks. The remedy is to require receipts and programmatic validation for every critical workflow, so no result is used until it has passed objective tests. Debugging mode. 3 concerns: sandbox versus native. If final outputs disappear after the VM shuts down, they were saved only inside the isolated shell. The solution is to direct Cowork to write final artifacts into a real, connected local folder that persists on the host system. To move Cowork into production, follow this checklist. Connect one working folder, add a single MCP write channel, pre-approve at least one scheduled task, and enforce a drafts-only default. The DDS Boston program is free and focused purely on helping you operationalize this workflow.